folks have watched his Pluralsight videos here, and he was an MVP seven times in a row, which is no small, easy feat. VSLive. And more importantly, his C# presentations are absolutely epic because he takes the source, he decompiles it, he shows you how things actually work under the covers. I think his presentations are honestly better than anything that you would see if you went to MS Build. And I mean that honestly. So I'm so excited to have you here. Thank you so much for joining us.
Thanks a lot. With that build up, I can only go one direction here. So let's make sure my screen sharing is in shape here.
I didn't break it for you.
Lost sharing, so I've got to debug that. Yes, I don't have sharing anymore. I used to have it. Did I lose presenter privileges?
Maybe I should have hit stop sharing.
Right. It's disabled. You can promote me to a.
Yeah. I'm trying to find it on the thing.
Found an allow camera button for you. That's not what you need. I don't think I have what you need.
You just. Oh, it's back. Okay. There we go. Okay, looks like we are in business. So I have to say that you don't know how happy I am to be here tonight. And I don't say that lightly. I presented here probably almost 15 years ago, not as far back as Scott. But the last couple of times I presented, it's just online, virtual. So there's very few user groups that have gone back to being in person. So this is a really nice change of pace. So I'm super happy to be here actually doing an in-person presentation tonight. So we're going to talk about C# 12. I am going to show you 2 slides and then we're going to spend the rest of the time doing code demos. For people that have seen me do C# presentations in the past, you know that I like to typically start with a little bit of a history lesson before we dive into the current version of C# that we're going to talk about tonight. And I think that's important because when you think about every time the language designers add new features to the language, it's good to have the context on what's come before and why. And so going back to 2002, I was looking at that picture of myself like, I might need to update that picture. It's kind of an older picture, but we'll let that go. When C# came out in 2002, C# 1, right out of the gate, it was an extremely robust language, full object-oriented interface, abstract classes, very impressive offering for a 1.0 language. Then, if we fast forward 3 years to 2005, we had C# 2. Now, this had many features that were added. We had things like static classes and anonymous methods and a range of features that were added to C# 2. But without a shadow of a doubt, the headliner was generics. And with generics, you could get away from things that we had to do in C# 1, like array list and boxing and unboxing and things like that. So without a doubt, generics was the star of the show for C# 2. .NET Framework 3 came out, no rev of the language, it's still C# 2. But then in 2007, we had C# 3, which corresponded to the framework version 3.5. C# 3 was also significant because, like C# 2, there was a host of new language features, probably 8 to 12 new language features that came out. And many of those features stood on their own. Lambdas and extension methods and anonymous types and things like that. And those were very powerful features on their own. But when you put them together, they formed Link. And so when you think about C#3, link was really the headlining feature. And so you start to see a theme here, where every new language revision that came out, yes, there was multiple features added, but there's always one feature that's really the headlining feature that gets all the attention from an innovation perspective. Now, when C#4 came out in 2010, there wasn't as many features. There was only about 4. And there's some COM interop enhancements and things like that. But the star of the show was dynamic. And the big joke was we could statically type things as dynamic. And it's been kind of interesting to see the evolution of dynamic over the years. I think there's some interesting use cases where that has had really, I think, valuable uses, but it's not something that is like taken over C#, like generics and like link. And like the next feature I'll talk about, which is in C#5, there's really only one feature that came out, but it was foundational, async and await. And not only did it really revolutionize the way we wrote asynchronous code in C#, but it literally formed what became the basis of TypeScript async and await, and now actually in the ECMAScript standard. So it's really interesting to see how those innovations took place. That C#6 in 2015, that was a little bit of a more interesting release because, yes, there was a bunch of new language features there, but there was no one feature in C#6 that was just this life-changing, headlining feature like generics was. There were some interesting things there like string interpolation and things like that. Great features that like I would use on an everyday basis, but not something that fundamentally was changing the landscape. And that wasn't a bad thing. If anything, that was an indication that, well, C#'s been out now for about 13 years at that point. It's an indication C#'s becoming a very mature language. And so the language designers we have to be responsible stewards, shepherding this language as we go, and not just gratuitously adding new features if we really don't see a community need for it, that they're going to be impactful and things like that. So C#6 was a great enhancement to the language overall, with the features added like string interpolation and some other things. But again, nothing earth-shattering. And you started to see this trend continue. So in C#7, it was a similar thing where we had things like tuples and deconstructors and things like that came in, local functions and some interesting pattern matching things. Really just things that enhance the language, not that fundamentally change the way we write code. And then in here in the 2017, 2018 timeframe, there were some point releases that came out, 7.1, 7.2, 7.3, that I think, unless you were paying really close attention, it was easy to miss those point releases. And a lot of those things that came out were things like async main, if you were doing console applications, and inferring tuple names and things like that, private protected, and just little tweaks to help with memory management enhancements if you were like on the compiler team and runtime team and things like that. But it was easy to miss some of those enhancements that came out. Then in 2019, that was C#8, and we had more pattern matching. We had indices and ranges. I would say the star of the show there was probably nullable reference types, where you have nullability turned on in your project. So whole billion-dollar mistake, the guy where null reference exceptions and things like that. So if you have that turned on, it'll show you possible null reference exceptions, and that was C#8's, I think, big one. In C#9, we got target type new expressions and more pattern matching enhancements. No question, the star of the show for C#9 in 2020 was records. And so records introduced some constructs that helped with immutable programming and things like that. Okay, now we're on C#10 in 2021, and we're back to the situation where, again, it's not any life-altering new features. A bunch of cool things were added, like global using, file scope namespaces, interpolated string handlers, and things like that. And some more enhancements to pattern matching. But C#10 was, just some cool new features. And C#11, I would say the same thing. I think if there was one headlining feature in C#11, it was probably the required members. But there's also some things like raw string literals and more list patterns and things like that. And I'll make the code samples and the PowerPoint, such as it is with 3Slive, available to people. There's a couple of links in this slide, which I do think are interesting from a historical perspective, and they're right here. I know it's kind of hard to see right here, but it just shows a lot of the features I was just talking about with, the different features that were in each language. I think it's an interesting thing to look at. And then some more .NET history here as well, which talks about the versions of the language and the versions of the framework as well. So some links you might find interesting as you go. Which brings us to C#12, which introduces 8 new features. There are a couple features here you're not going to use much, and I'll point them out when we get there, and I'm kind of leave those towards the end. The 2 ones that I think are going to be the most interesting, the first 2 I'll cover are primary constructors and collection expressions. The first row, I think you can use a lot. The last row, those will be quicker demos at the end, but we'll talk about all the features. So when you leave out of here tonight, you will have a firm grasp of every new feature that was added in C#12 because it is these 8 features right here. Okay, so with that, let's get into a demo. So I'm going to come in and create a new project in Visual Studio just to prove to you I'm creating a console app. This is a completely blank application. Call this CS12 demo. And just and you can see I've got .NET 8 selected right there. And so that'll put me into the C#12. So let's let this create. Okay. Now I'm going to do a couple of things here. First off, I'm going to add a new class called person. And what I'm going to do is I am actually going to change this from a class to a record. And I'm going to add a couple of properties to it. So, and you know, another thing is with these demos, I don't have to use snippets nearly as much as I used to because Copilot's trying to do my presentation for me half the time. So we'll let it participate in here. And so I don't really want birthday. I'll have age instead, just to make it a little bit simpler. But okay, so now I've got a person record, and it's not a C#12 feature. It's a C#9 feature, which is just records. And we'll say with primary constructor, because the fact is that primary constructors, which you just heard me mention a second ago, are new in C#12. They're not really new. We had primary constructors in records. What I'm about to show is we now have them for classes. But first, let's start with our history, which is C#9 for records. So again, just to look at it very closely, I've got my record person. It's got first name, last name, and okay. So let me go over to my program CS over here. And we're just going to instantiate a new person object. And let's not use John Doe. Let's use Steve Michelotti. And it didn't resolve my namespace for me, so we'll resolve the namespace. And say Michelotti. And, you know, I just made a comment about the picture being old. And I just became an empty nester this year with my kids going off to college. So you guys you'll bear with me if I say it. My age is 21. Okay, so I've got my person in there. And so good. So let's console write something out here. So we'll just use some lightweight string interpolation. So we'll say person.first name. We'll put a little space in there for readability and person.last name. And we're good to go. Okay, so let's run this. Nothing too exciting so far. Compile it for the first time and output, yes, okay, Steve McLeod, great. Okay, now what we're going to do is let's tweak this a little bit. I'm going to go back to this file over here where we have person, and I'm going to change this from record to class. And now let me run it again, and I can't run it. It's immediately giving me a compile error. Well, there's no error here. Yes, I'm getting some squiggles, compiler warning, but that's not an error. If I come over here, this is where I can see the error is. It's saying this person object, this class you tried to instantiate, that you did instantiate, it does not have a property called first name and last name. And so this is the first significant thing to really be aware of as a difference between when you're using records in C#, you declare that primary constructor, it's going to auto-generate read-only properties for you behind the scenes, or not necessarily read-only if you use the init qualifier. And a class, it's not generating that for you. Okay, so let's continue to build our functionality out here. So what I'm going to do is let's come back to this person class here, and let's add some implementation to the body here. Sure, why not? Let's let it help us out here. And I'm going to just use setters here. Not going to use a init. A init is when you're using the initializer. And the other thing I'm going to do is I'm going to actually change up here in the constructor. I'm going to change these to lowercase to make this look a little bit more like an actual constructor argument where we would typically use lowercase there. And then at that point, I will just assign each one. And so I'll do that. Okay, initialization. And now those squiggles are gone. There's no more compiler warnings in this class. And certainly I was able to run it just fine. So the compiler errors in the program.cs are gone now because I have the properties. So when you use it in a class as opposed to a record, you are in control of actually creating those properties yourself. Now let's dive a little deeper here in some of these code examples here. This also works for basic inheritance. So I'll create another class. We'll call it business contact. Is it going to help me out? IntelliSense? Yes, no? All right, that's all right. We'll just, Copilot will eventually catch up for me here. All right, so we're going to inherit from person. Yes, no? Okay. Sometimes it does, sometimes it doesn't. All right, so we'll send last name and age in here. And the other thing is, because this is a business contact, let's actually add a company property as well. Okay, so because we are inheriting, we are going to just pass the first name, last name, and age into the base class. And then here, we'll just create a property for company, which Copilot was nice enough to give me here. Okay, so now we're in good shape. We're illustrating that this is actually working just fine for an inheritance situation too. Let's just real quick show this in action. So we'll come over here, we'll say business contact, new business contact, and just for clarity, we'll make this Bill Gates so we don't conflate that with the normal person here. We'll put his real age in here. Okay. Now, what I'm going to do is I'm going to also kind of output a similar thing here. Let me just copy and paste this just to save on typing. And so we'll make this first name, last name, and we'll just add company on here just to prove that, yes, this is the business contact. Oops. So it works exactly like we would expect. We created this business subclass, this business contact. We had a primary constructor that had all same arguments plus an additional argument for company. We passed 3 arguments down to the base class. Really no different than what we would have done in C#1. It's just that we're doing it on the primary constructor. So the takeaway there is primary constructor is going to act the same way as far as the constructor chaining is going to act basically the same way as what we had in all versions of C#. Now, let's go a little bit further here. I think when people first see this, they think, all right, well, this is cool. I'm saving on some syntax on like having a whole separate method for the constructor. And I can see that these initializations here are happening, but sometimes it's a little jarring the first time you see it, that it's not in the constructor method, but that's okay, you just get used to it. But it's still like a constructor. So I'm assigning these in line, or sometimes in a constructor, you actually have business logic, maybe checking for null or checking for a range and things like that. It's no different. You can do those exact same things here. So for example, I could come in here and say age is greater than 0 and less than 100, then great, assign it. Otherwise, and we'll have Copilot accept, out of range exception, age must be between 0 and 100, okay? So everything still acts the same. This is exactly the code you would have written in a normal constructor. Note I used pattern matching from C#7, so you couldn't have written that in C#1, but everything else acts the same, all right? So just like you would put little validations in your constructor code, checking for null argument exceptions and that kind of thing, no different. You're just going to save the number of lines of code you have to put in your class to do. Okay. Now, it's not all sunshine and rainbows here. So let me show you a couple of other interesting examples. Let's come in here to the person class, and I'm going to add a property here called full name. And what I'm going to do is actually, instead of the property, I'm going to use the constructor argument. And so notice really carefully, you can see I put the lowercase f and lowercase l. So I'm not referring to the property name, I'm referring to the actual variable up there. Now for the astute observer, you may have noticed that when I did that, all of a sudden, I got these green squiggles under the assignment, which previously it was perfectly happy with. It didn't put the green squiggles on there until I added that full name method. If you look at the warning it's giving, warning being the operative word, not an error, it's not necessarily wrong, but it's warning you it might be wrong. It's saying first name is captured in the state, a closing type, but it's also used to initialize a property. So we can see the property initializing here. That's just going to happen. We're also using it in this enclosing type in this full name property. Let's see what the ramifications. Let's see exactly what they mean by that. Right. So I'm going to come back here, and we'll just do it above the business class, so the regular person class here, and we'll just console write here the full name. And it's person.full name. Okay. So far, so good. We won't worry about the business class. Don't worry about Bill Gates yet. So far, so good. There's Steve Michelotti, full name Steve Michelotti. Everything is what we want as we expect. But now let's come in here and let's say that person.first name is Bob. So now I'm just going to copy this line and paste it down here. This should say Bob Michelotti, because I just assigned first name as Bob. But when we look at it, it doesn't say Bob Michelotti, it says Steve Michelotti. So let's look a little closer behind the scenes as to see why that might be happening. So I'm going to open this in ILSpy and have a look at like what the compiler is actually doing behind the scenes in this code. So here's the decompiled person class here. And if we look at the constructor, and this is the constructor, you can see the primary constructor may be what's on the C# class we write, but behind the scenes, it's a real C# constructor. But what happens is when you have these parameters that you pass in, these constructor parameters, the compiler creates a backing field behind the scenes. Now, it does it in this weird angle bracket syntax, which would be illegal for us to use that as an identifier. The compiler gets to do whatever it wants. So it has this backing field here. It assigns it here. Then it does the initialization of our properties, which correspond to the lines we had above. Notice the pattern matching. It changed to more of a traditional C#. I said if age is less than a greater than 0, less than 100. But did I get those wrong? No, it's good. Okay. And then it called the base constructor. And so then what happens is the full name, because I referred to the parameters, then what happens is in that full name property here, it actually referenced the backing fields, which got assigned when we first went in. So when I assigned it to Bob, cool, Bob went right here. If I did console write line of first name, it would say Bob. But because I did console write line of full name, it said, oh, let me go back here and grab the thing that you originally put on. Hence the compiler warning. And so it's something you watch out for. Okay. So it can get even worse with inheritance. So let me just real quick reiterate. When we have a capture situation like this, that is when the compiler will generate the backing fields. So in this person class, it has generated these extra backing fields for first name and last name, because I identified if it was just here, I initialize them once, I'm done with them. Oh, no, they're going to be used again. Okay, I'm going to create some backing fields so we can come back and refer to them. So it actually created an extra copy of each of these variables, not the age variable, because I didn't use it. But for first name and last name, it created extra copies of the variables. Now, let's look at an inheritance situation. So in the business class, we'll come in here and let's actually override a toString method. toString. And let's just do this. I'm going to do an expression body member so we do this really succinctly. And yeah, we'll do something like this. Full name. Let's just do like this to make it even more consistent. First name and last name is what I want to do here. And then we'll add company onto it. All right, great. So now at this point, what we're going to do is I've overridden the toString method of business class. So now let's come in. We've already outputted the business class on line 13 here. So now what we're going to do is we're going to come in here and change business contact first name, Melinda. All still same last name. Okay, and then let's do a couple console write lines here. First thing is I'm going to copy and paste this console write line, and then I'm going to do business contact toString. Now let's see what happens here. We know the Steve Michelotti thing is off. Bill, okay, cool. We referred to Melinda, and then we're back to Bill again. Because if you look at the lines of code that I actually wrote, we knew this one was going to be Bill, great. Then I changed Melinda and I directly referred to first name. So it saw Melinda was there because I changed that first name variable. It recognized I changed that variable. But in the toString is where I referenced the original capture variable in the parameter, that was back to Bill. So if we look at the decompiled code for this, not only in the base class do we get these backing fields generated here, that was not what our intent was, but in the business contact class, open that back up, we got 2 more copies of first name and last name. So there's now 4 extra copies of those variables floating around. So don't ignore the compiler warnings. Okay. So this is not to say don't use primary constructors. It's not to say don't use primary constructors with inheritance. No, do all those things, but do it the right way. So this is a really simple fix. If I change this to, and did you notice IntelliSense didn't even help me? First name, like I couldn't even get first name with the lowercase to show up in IntelliSense, but last name did show up. So let's come in here. Let's do the same thing here. Let's put the F, so referring to the properties. L, company, that was already uppercase. I missed that one. So all of the compiler warnings are gone. And now all of the code is behaving exactly. There's Bob Michelotti, there's Melinda, and it's still Melinda. Doesn't matter if I'm referring directly to the first name property, if I'm using the full name or the toString. It's the capture versus the assignment. Got to be careful on that. And now let's look how clean we are if we refresh our code over here in the person class. Look at this constructor now. Now at this point, there were no extra backing fields created. Those compiler generated backing fields, no. It saw that I only use them for assignment, so they're only used in the constructor, so there was no reason to create any of those extra backing fields at all. So in this instance, it was very easy to kind of fall into the pit of success, so to speak, because in this instance, we weren't mutating the state of the constructor parameter variables that were passed in, which makes sense because like even in normal C# classes, that's what we would do. We would pass constructor arguments in and typically do assignments at that point. Okay, I'm going to keep going deeper into the primary constructors. Any questions on what you've seen so far?
There's a little bit of a chat or
questions
in the chat around tuples and like the differences, but I think tuples. Yeah. They're asking are records like tuples.
Records are not like tuples. Records are classes. It's just their classes that get generated. And actually, we'll talk about tuples, interestingly enough, in a few minutes. But you should think of records more like classes themselves. I mean, if we decompile the record, it actually shows that a record is a class.
There's also a question, is there only one constructor or a class? But I think that might have been a record. So we know that constructors can have classes can have multiple constructors.
Yes, but that's actually, there seems to be a question. Let me just go and look real quick here. Like chat in here. Okay, there's only one primary constructor for class. So I'm going to kind of tweak that question a little bit. Yes, classes can have multiple constructors. Always been the case in C#1. You can have multiple constructors, constructor chaining. None of that has changed. But you can only have one primary constructor for a class, which makes sense because the whole thing of a primary constructor is it's right there by the class declaration. There's some rules around primary constructors and how constructor chaining has to work, which I'm going to talk about in a second. So I'll ask you to bear with me for 5 minutes until I get to that point. Okay, back to the code here. So I want to dive even deeper on this idea of mutating the state of the original primary constructor variables that were passed in. So what I'm going to do is create yet another class here, a point. In this instance, I'm going to make this a struct. because I want to show that primary constructors can work on primary constructor on structs. And what we'll do here is we're just going to say that we'll pass in an X coordinate, a Y coordinate, and we're going to add one method for distance from origin. And thanks to Copilot, I don't have to do much typing, so we can kind of simplify the distance equation if we know we're coming from the origin, x squared plus y squared, square root of that. Okay, so save that. We have this simple struct type. So let me come over here, back to the program.cs. I'm just going to put this under the Bill Gates stuff. And let's just declare a new point equals new point 2, 3, and then we'll write out distance from origin, and let's run it. Okay, so x coordinate, y coordinate, the distance from the origin is 3.6. Okay, cool. Now, let's say we actually want to change the state. We actually can, theoretically, mutate that state safely. So I'm going to come in here and add a public void method here called reset. And it's going to take in a double. We'll call this new x and a double for new y. And then in here, we'll actually do the assignments. So in this case, if we run here and it's a p dot or reset, and now let's just pass in like 3, 4, should be like a right triangle or something. Now we've spit that out again. Now we're going to see that, oh, actually everything was good. We didn't run into any of those weird scenarios where Bob Michelotti didn't show up, or we were expecting Steve Michelotti, Bob Michelotti. The state mutated just fine. And if we take one closer look at that class, what we can see here is, yeah, because this lowercase x and lowercase y in the constructor parameter was in fact what I was changing. So the compiler generated those vacuum fields. And when I said, I want to change the state, it's going to do it against the actual vacuum field. So here I'm safe and no compiler warnings. So again, this is a little unnatural. I'm not saying I would necessarily write a class this way, where this is how I would mutate the state, but this is a talk on language capabilities and language rules. So I'm just here to communicate what the language rules are. Not that I would necessarily write code this way to mutate the state. Yes, sir.
Does that same thing work with classes where you don't actually have to declare the property X and Y?
Well, yes, it would be the same. Yeah, so a class with a primary. So I could have done the same
Those
demo.
properties are implicit.
Yeah. So and just to be very precise, technically they're not properties, they're
Gotcha.
fields. But yes, I could have
They're
done.
not getters and setters. They're actually things.
I could have done this demo on the person class. I'm just showing there's no difference in the fact that I'm using a struct. I could have done this on the person class. The rules there are the same. Now, having said that, there's one final kind of thing I want to show in this example. At first I said to myself, okay, well, as long as there's no compiler warnings, you're safe. But what I realized is that's not quite true, because the compiler is not capable of reading your mind. And let me show you an example of what I mean. So notice really closely here, we have the fat arrow syntax. So when it comes to this concept of capture ramifications, it's expression versus assignment. So this is a fat arrow, so it's an expression. We're going to invoke this thing. But let's say I take the arrow out. So now it's just an assignment. And just by that one code change, now look what happened. Right? Because if you think about what happened there, let's change it back. It's bugging me that we have bugs in the code now. If you think about what happened, now we're kind of back to that exact same situation I showed you in the person class, where, okay, it was if it's an equals, right? If it's just an equals, then this assignment is happening one time on initialization on the constructor and is done, and you can never change it. Whereas, and I've mutated the state here, great, you mutated the backing fields, but it's too late because the capture variable's here. Whereas if we do the expression body member here, it's going to re-invoke like a method. So that's another thing that I was watching a presentation, actually I think it was from .NET Conf, on listening to how the language designers were talking about this. You know, they are thinking quite a bit about how they were going to implement this feature. So for the most part, if you think about the classes we write on an everyday basis, we're not going to run into this stuff. We're going to do the initialization, maybe some validations before initialization. It's going to work how you want. So I don't want anyone walking out here like, oh my gosh, these primary constructors, I'm staying away from the, no, I think this is a great feature. It's going to save number of lines of code that you have to write. I'm simply trying to make sure that people have the full sort of knowledge of all the things to think about. Okay, now let's go even deeper. I'm going to come back to this person class here, and we talked about multiple constructors. Yes.
Question, with a primary constructor in the class, can you expose those parameters as properties without making properties, such as like an access modifier, like you can of TypeScript or Kotlin? So just say, here's public, so I'm not gonna make my own property here, but I'll just be exposed.
Let me make sure I understand your question. You're saying, could I create my own properties that encapsulate those fields?
No, make first name and last name be available without creating properties.
Oh, by just making them public?
Yes, once you instantiate it, make it public, to put an access modifier on the properties, on the parameters themselves.
You can't, like, this thing is a variable you can't control. You have to either do something with it, like assign it to something, or use it in an expression. But for what you're talking about, you can't just say, hey, make this public, and this is now this public member of the class.
Right.
You have to do something with it, like an assignment.
But you can with records though, right?
Well, with records, that's a little bit different. What happens in records is it generates a property for you. So it's not that you're doing something with the parameter, it's that you have a parameter and the record is generating an actual property that is there. So, yeah. Okay. So let's add a parameterless constructor here. So I'm just going to say public person. And by virtue of adding this parameterless constructor here, I can just say, oh, actually, IntelliSense is helping me here. Sure, let's accept the default here for John Doe. And let's just compile it. Okay, so I wanted to compile it so that I could come over here and refresh ILSpy. So if we look, we sure enough have constructors that have been generated here. So if we look, this is the parameterless constructor, and it's calling into the primary constructor, and that is unchanged. That primary constructor always looks like that. All constructors, if you use primary constructors, all constructors must resolve to the primary constructor. It's a rule. Okay, and there's a couple other rules too. I lied when I said I had no more PowerPoint slides. I have two. Here are the rules. The reference link down here is a direct copy and paste of this web page. Primary constructor parameters may not be stored if they are needed, meaning the compiler may generate those backing fields, it may not. And I showed you examples of, this is the example of compiler is going to create the backing fields. This is the example where it's not. The code as we have written, those backing fields aren't created. Second one is primary constructor parameters aren't members of the class. You can't refer to them as this dot first name, not with the lowercase f that I have. So even though, yes, the compiler technically generated a backing field, you don't get to refer to it directly. You can only refer to it indirectly. Number three, primary constructor parameters can't be assigned to. Yes, you saw me do it in the point example. Number four, primary constructor parameters don't become properties. The only time that happens is in record types. And then finally here, every other constructor must call into the primary constructor directly or indirectly in that constructor chain somewhere. And I showed that example. Even with the parameterless constructor, that had to call into the primary constructor. And I showed that example and exactly how it is working behind the scenes, disassembled code. Now, yes.
Is that this syntax, does that only apply to the primary constructor, or is that general that you can refer to other constructors with this?
You're talking about the syntax where I use this? That syntax has been there since C#1.
Oh, okay.
Yes.
I was not aware of that.
Yes. Typically, it's that I'm referring to like maybe I have a constructor with, 3 parameters, and then I have one with 2 parameters, and the one with 2 parameters refers to 3 or whatever. But yeah, you can, and there's also a base.
I knew base.
Yeah.
I just was not aware of this.
I think there's another question.
Same question.
Okay.
Couple questions from online.
Okay.
You were going to share the slides for the GitHub repo? Where the GitHub repo is?
Oh, I'll at the end. Yeah.
And then assuming primary constructors are available to use, can API controllers too, since they are classes? And does they work with dependency injection?
That's my next demo. Okay. So, use cases. Number 3, dependency injection. I'll get to that in a second. Number 1, argumentative base class constructor invocation. I showed you that when I had the subclasses with the person and the business contact, and initialize a member field of the property. I showed that where, simple first name is initializing the first name property. Referencing constructor parameter instance member, especially DI. This example is the one I'm going to show next because I find, well, I'll show you in a second. Okay. So for this, I want to talk about dependency injection for a second. And so I'm going to create a fake API controller. We're just going to call this get contacts list endpoint, not really a true controller. So type that right, list endpoint. I think that's right. Okay. All right, now if we look at what I just generated here, oh, and actually let me make this public. That's why I'm getting the compiler here. Okay, all good. So this is very traditional setup for what you would expect as you're writing code pre C#12 for dependency injection. So I have a class right here, and then I have these 4 properties right here, these private read-only properties. I have a logger, I have a repository, a formatter, a mapper, fine. I have a traditional constructor down here. It's passing those 4 things in, and then the assignment is in here. And maybe I do some checking inside the constructor to make sure it's not null, throw null reference exception, argument exception. Traditional, we recognize this as a very common constructor injection DI pattern. Okay. So let's comment this out. And let's see if Copilot's going to help me out here. Let's going to say convert to C#12 primary constructor. Boom. Okay. Compile. Everything compiles successfully. So what's happening here is if I look at this constructor repository, if I right click and say go to definition, boop, it jumps me up here. I don't know if you can tell my cursor is blinking, but it just went right up to that one. Whereas if I should have done go to definition before I made that change, it would have taken me right here to line 7. But those are gone now, and it's referring directly to this. So I think this is actually pretty cool. And if I was writing some kind of side project on the weekend, I'd probably be fine using this code. And Microsoft actually sort of recommended this on their website. For a professional project that I was doing at work, I wouldn't do this for 2 reasons. And I'm going to be very specific about what those 2 reasons are. Number 1, notice that if you look at the original code, I had the luxury of declaring them all as read-only. And now that's gone. So I could actually come in here to my method and start like assigning like, the logger to something else, whatever. And that's really not what I want to be able to be allowed to happen. That's point 1. And point 2 is you might want to have some validation. Like, is this thing null? If so, don't inject a null logger into the class, that kind of thing. So what you can do, which I think is a good middle ground, which I would accept in a professional project, is if we bring these back, so let's uncomment these. And then if we come in and say, just do the assignments like this, then we're in a situation, contacts, spell it right, contacts, repository, yeah. And contacts, this format. And then again, we can even do things like, if the mapper is not null, then great, so that now you have a situation where, okay, there is no difference in the code. I get the benefit of the read-only. I get the benefit of being able to do my simple validations exactly what I would have done in constructor. I've lost nothing. And I've gained more succinct code because I just saved like 8 lines of code. So I didn't save 12 lines of code. Again, my weekend project, I'm fine saving the 12 lines of code. And I'll trust myself on the injection. But for a professional project, I recommend save this code for yourself, do this, keep it read-only, have your validations exactly, and you'll get an opportunity to save lines of code, save some of the ceremony. Okay. One final, if it's possible, more example for primary constructors. Let's say that I have a little attribute here. This is a dummy attribute. It doesn't matter what it's doing. It doesn't even have implementation here. It's just a logger attribute. Okay, that's it. And I want to use this attribute somewhere. So I can come in here and apply this attribute to the class. All right. Now, when you in C#, when you apply attributes to things, I can apply an attribute at a property level on top of a method. But in this instance, what have I applied the attribute to? Maybe it's the class. Maybe it's the primary constructor. Before primary constructors existed, you would never have to ask that question. You would put the attribute down on the constructor, or you would put it up on the class, and there would never be an ambiguity. But now it's like, well, this line of code is my class declaration, but wait, it's also sort of doubling as my constructor declaration. So which is, well, let's prove it to ourselves. So if we come in here and refresh, oh, okay. It was on the class, put it on the class. But that's not what I wanted. I wanted actually to apply the attribute on the constructor. So what you can do when you find yourself in this situation is you simply come in here and you add this method little label thingy to it. And now when you refresh it, now you can see that it's moved down to the constructor.
And I'll present clues about a new series.
I know there may be some of you are sitting there saying, yeah, but if you go to the actual attribute declaration, this right here, you set this to all for the attribute targets. And if you just set that to constructor, you wouldn't have had that problem. No, you still would have had the problem, because if I had set this to only be allowed on constructors and applied it at the class, it would have said, you're trying to apply this at the class and it's only allowed for constructors. So no matter what, if you're in the situation where you want it to be on the constructor, you do have to apply that little method. Okay. Any remaining questions on primary constructors?
Can you do named parameters? Is that one way you can get around of saying how many parameters you put in?
So when you say named parameters, you're just talking about as far as like constructor overload resolution?
Yeah.
Like in the case where you have multiple constructors
Or
and
just in general, if you have a function with multiple named parameters, you can kind of choose what you put in.
you can,
Could you do the same thing with a constructor like this?
yeah, I mean, you can always use named parameters in constructors. And if you have a primary constructor plus other constructors, you're talking about for resolving which constructor gets called.
Right.
Yes, that will always work in any version of C#, as long as you're following the rules, which is any constructor you write must ultimately resolve up to the primary constructor. But for the person consuming your class, that doesn't matter, right? That's just a rule you have to adhere to as the author of that class. The consumer of the class can use those named parameters if they're trying to figure out which one they want to force it to call. So that's all fine. Okay. So what I'm going to do here is actually let's take this and I'm going to put this in a global usings file just so we store it off for later. Global usings, and let's just get in here. That way I can delete it from this and I won't worry about it muddying up the waters. So what I'm going to do is I'm going to extract this and we'll just call it primary constructor demo. And I'm just going to set it off to the side. So for the people that want to download the code samples later, you can fully reconstruct my demo. But for the sake of this discussion, I am going to hide it so it does not distract from the upcoming code demos. We start from a clean slate. Okay, so the next thing I want to talk about is collection expressions. So if we think about like a typical way that we might declare an array, a simple integer array. Let's just do this, 1, 2, 3. Okay, this is syntax we have been able to use for multiple versions of C#. And so there's nothing really new or innovative about this again. That's just like basic ability to declare this. But what's a little interesting here is that I think that it's kind of bugged C# developers for a while is the syntax still is a little bit weird. I mean, normally when we think of arrays, we think of like the square brackets, and then it's making us do this weird thing with the squiggle brackets. And this is actually where the JavaScript developers laugh at us because they're like, no, square brackets, it's an array. Just do 1, 2, 3 in square brackets, it's fine. And we can't do it. And so now we can. So what we can do here is I can just come here and let's just delete. Where'd my cursor go? Oh, no, I don't want to turn in sticky keys. And I can just delete that. I'm used to my big clickety-clack keyboard and I'm on these laptop keyboards now. Okay. So now I can just do the square brackets. Now, you might notice that I have this nice square bracket syntax now, but I do have the red squiggle, which is always a little unsettling. And the reason is because, okay, I see that you want to do an array, but because you used bar keyword, I'm not exactly sure what kind of collection you're asking me to do, is what the compiler is telling me here. So in this case, I can just come in here and say, okay, yeah, it's an int array, and then we're all good. So here is a collection expression. Now, the other thing is not that we've made an array initializer prettier syntax. That's all well and good, but it's a little bit of a broader situation than that. So if I think about all of the different ways I can declare collections in C#, it's a lot. So just an array alone, I can do this, I can do this, I can do this. If I want to do an empty array, I have this method, this empty method I can call. Or in a list, I can do a list like this. I can do a list with a target type new expression. I can send a parameter into the list constructor saying 3 items, spans. There's different ways to do spans. Empty dictionaries here. If it's an immutable array, I have to call this, so long I can't see it here, I have to call this method for immutable array.create. And then when I come in down here, I have things like read-only spans. I can do that a few different ways. Let me get this out of the way. And then let's say I have a couple things I want to declare as IEnumerable. Well, maybe I want to do it as an int array, or maybe I want to do it as a list. I really have to make all those decisions where maybe I don't want to make the decision. I want to use something efficient. Just give me something IEnumerable. And then jagged arrays, that gets into another thing because we have this like bizarre like nested curly brace syntax. So we have the square brackets here, but the nested curly brace syntax here. Wouldn't it be nice if we could just have one unified syntax for all collection initialization? So rather than delete this code, I'm just going to comment it out. And then let's just see what it looks like using the new C#12 language features. And now there's no decision making in terms of like how you do an array. It doesn't matter about pre-allocating this and that. It's just empty array. Can't get easier than that. List initialization. Can't get easier. In fact, it looks identical to what we did for the array initialization here. We can use this to create an empty dictionary. An immutable array. Exact same thing. I didn't have to call that immutable array.create method and figure out what was that method I'm supposed to call when I create the immutable array. Nope, compiler will remember that for me. I don't have to remember that. Now the IEnumerable one's interesting. I'm going to come back to this one in a second, because in this case you say, okay, well, what did it actually create for me in IEnumerable? In this situation, you're basically telling the compiler, like you decide what to create for me, and what the compiler is going to do is it's going to create something efficient, fast, and read only. And you don't really need to worry about it. Of course, we'll look in a second. It's great, but like you're just saying, I just want some fast read only IEnumerable thing. And so we'll get to that in 1 second. Okay, now let's also look at these jagged arrays. So this is also way simpler syntax on the jagged array. And we can do more here as well. So let me bring in another snippet here. So we have a 2D jagged array, and then we also have this jagged array from variables here. So let's come in here and iterate the 2D jagged array. Boom. My demos will never be the same. Copilot. Okay. So nice little nested for each loop. Okay. I have the multiple arrays, jagged arrays. Okay, great. Iterated them. And the syntax was so much nicer. And not only that, I can flatten the array really easily. So if I just say I want a single dimensioned flattened 1D array, did I spell that right? ED, 1D. What I can do here is, this is where Copilot hasn't really caught up yet. I can say dot dot row 0, dot dot row 1. And so the difference here, well, actually, let me output it first, and I'll talk about the difference. So this is the flattened. And so we'll just output it. So now I don't have a multi-dimensional array. It's just a flattened array. So it took this jagged multi-dimensional, put it into a flattened single-dimensional array. And so the difference when you see that dot dot syntax is it's not the array itself, it's the array elements. And so it's just like, hey, whatever the elements are, stick when you see the dot dot, just stick the elements in here. So it's almost like you're just kind of concatenating this array together. So that's why this is just a flattened single array. So it's actually kind of a lot more like JavaScript syntax now. Okay, now, of course, we have to go to our trusty ILSpy here to look at a couple of the things that are happening behind the scenes. So let me come over to here into the main method. Okay, so a couple of things is it's still doing the syntax. It's just like we didn't have to write the ugly syntax. It did it for us. It's still calling array.empty, but we didn't have to do that. We could just do the very succinct square brackets. It did some very efficient things when it came to the spans. We'll come back to those. And also the IEnumerables are the ones I really want to look at here. So if we come down to the IEnumerable, it actually created those exactly the same. It did a read-only array. It pre-allocated it to 3. And this is another thing the language designers talk about. They're just trying to give the most lean and mean data structure to give you that read-only array. And so if we click on this auto-generated type for read-only array, one thing I'm gonna go back here. On the spans, we have this other thing here where it's doing the same thing. The span is 1, 2, and 3. And it's doing the span, it's creating buffers. Like I don't want to worry about dealing with any of the buffers or anything like that. And it's got this, again, compiler generated type here, inline array 3. Because remember, these were 3 objects in the array. Notice there's this inline array attribute right here saying it's going to have 3 items in here. For now, just note that. I'm going to come back to that in 5 minutes, and we're going to talk about that a little bit more. But for now, just note that it's pre-optimizing, pre-allocating 3 and only 3 items to make sure that structure is super lean and mean. But back to the collection of initial expressions. Strongly recommend you use these just to make your life simpler in terms of like syntax, unified syntax. I don't have to wait. The dictionary initializer, well, dictionary initializer syntax is still a little wonky, but very much simplifying how you would deal with this going forward. Yes.
Someone asked if there was an overhead to it, but it sounds like this is actually.
Yes, so it's the exact opposite. So it's talking, is there an overhead to these collection initializers? It's the exact opposite. It will get the overhead out of it. It's going to write more efficient code than you would have. I think sometimes what happens is people say, oh my God, all this it's compiler generated code. No, that it's almost like it's kind of like generating machine code. This is more efficient code, the way it's writing it than what you would write. Because you might write code that's only 2 lines of code and it just wrote 10 lines of code, but your 2 lines of code isn't pre-allocated where it's got the buffer that's only 3 and only 3. So it's allowing you to be succinct and efficient. The compiler will be verbose and efficient. So yes, the overhead is definitely less, especially with some of these initialization scenarios. Okay. So let's take all of this. And this is the collection expression demo. Set that aside. Okay, next thing I want to talk about is aliases. So when we talk about alias, we've been able to do aliases in .NET, in C# with the using keyword. And there's several different forms this has taken over the years. So the first one here, I'm gonna skip the first line. We're going to do this chronologically. Is we can alias a namespace, and we've been able to do this in C#1 back in 2002. So I say, I'm just going to give this MS-JSON. I just created that. That's going to alias that whole namespace. Maybe we won't want to avoid a naming collision, or maybe we just want to make it more succinct, whatever the case may be. Alias of namespace we've been able to do for 22 years. Next one is in this case, you have alias a type. And this is something we've been able to do since C#2. So this was introduced in 2005. And this is a situation where maybe I'll have these parameters, these like generic string, and it's a little noisy on the syntax. It gets a little verbose. So I just want to create this alias to make it simpler, more succinct syntax. We've been able to do that since C#2. This was added in C#6, using static system console, and everyone always complains, oh, it makes it like VB, where I can just say write line, and I don't have to say console write line. But that's something VB always had. C# got it in C#6. And then the last one here is we just got this in C#10, but I put it on the top because it's global usings have to go before everything else. And so this is, if I say global using, then I just have to put that in one file, and it'll be there for all files. And I kind of, you saw me do that a little while ago because I created the global usings in here when I wanted to store that away, so I don't have to keep adding it every time I move the code. So if I save this, they all disappear because my IDE is set to on save or move namespaces that I'm not using. So what I'm going to do is, let me just bring that back, and I'm going to comment those out so that you can still see them, but I don't want them to disappear every time I save the file. Okay, now let's talk about C#12. Now we have a new feature where we can alias any type. So those were great that we could alias those things before, but now they've really expanded the functionality of how and what you can alias. So I can do something like this where I say using coordinate, and I can say something like system.decimal, and that works just fine. Sure, okay, I'll take the comment suggestion. Not only can we do that, which we can never do before, we can even do the keyword equivalent of that. That also works. We can do something like coordinates, plural, coordinates, and we could do something like decimal. Okay. Yeah, even all that works. We can even do something like this, where you say using point. Actually, before I do that example, we can even do unsafe context. Using unsafe, coordinate PTR. Now it's giving me the red squiggle because I didn't turn on the unsafe option in my project properties, but syntax-wise, we're fine. What I'm going to do is I'm going to comment those three out so we can see them, but they're not going to mess with our compiler or anything. And then the other thing I think is really cool, and I think this is where you'll see people use it very often, because like how often you really want to like alias decimal, but tuples is an area where I think you will often see people alias things because we have these kind of best practices rules, like don't return tuples from methods and things like that. Well, if you can alias it with something logical, maybe you can relax some of those rules. So we can do something like this, where we say using point 2D, and we can just create a tuple, decimal, X and Y. And that is perfectly fine. So, and that was in really C#7, right? I was getting this wrong, isn't it? I thought that was C#7. I think it was C#7. I don't know. Maybe I'm wrong, but I think it was C#7. So tuples were introduced in C#7. Okay. And then let's look at how we can use this thing. So let's say I can say var p1, and this is, I'm just going to do regular tuple, no alias here, not using the alias. But then if I say, oh, sure, okay, GitHub's Copilot's just taking my whole demo away. So this one here, this is the right side of the equals same. So here I aliased it. So now I can always refer to that as point 2D. Whereas if I mouse over this, you can see it's just int. It doesn't really know what it is. If I mouse over it, it says, oh, this is point 2D, which is really just decimal. Okay. Now, a couple more interesting examples here. Let's say var p3. I can do in here where I can come and say new point 2D. And this is what I made this up. This is not Microsoft documentation. I refer to this as a phantom constructor. Because it's like, there's no constructor. Like, this is a tuple. The tuple looks like this. Like, I'm not even sure how it's letting me do this, but actually I think it's pretty cool. It's a little trippy, actually. So I call it a phantom constructor. But it works, it can do it. So if I want to put the 2D on the right side and I can use var on the left side, that is also perfectly legal and valid. I can also do something like this, point 2D, where P4, and this is going to equal new. And this is what I refer to as phantom target type new, which was C#9. Right, where I can just say the new keyword and I don't have to put in anything. All of that works. We can also, deconstruction also works. So I can come in here and say decimal X, decimal Y, and I can deconstruct any of these variables. Let's deconstruct P4. That's valid. Instead of deconstructing on the individual variables, maybe I want to deconstruct them into P5, which will have properties of X and Y. That works too. And not only that, I can come in and use the actual alias here, point 2D. It all works. Compile, build, all good. So as far as my commentary on this, like, I don't have any big philosophical problems. Yeah, probably still make sure you're using things responsibly, like you want your code to be readable. But I think there are opportunities where you can use this to make your code more readable, especially when you see tuples all over the place. Sometimes it would just it kind of makes it look a little bit more like a class. Like, hey, pretend this tuple has a class name, and it looks nicer to use that in a method signature than that in a method signature if your method's returning a tuple. I think that would be an opportunity where you're responsibly using this feature. Yes.
There are no constructors though, right? So you're not getting the penalty of having to construct those.
Well,
It's just a concise aspect of the language.
well, you know what I'm going to do here. It's the tuple is still a class, right? And so there's a constructor.
Oh, really?
Tuple is
Tuple
still
is
a
always a class?
Yeah, it's still. So if we look at what's happening, let's come in here and let's refresh because I think that's a valid question. So if we come in and look at the main method, and actually it's. Let me see if I can do this on an older version. How old can I get here? 5? Yes. Okay, here we go. So I had to go back to an old enough version that wasn't smart enough to know tuples. This is just like values. Actually, that's a struct. But so you have tuples that can be structs or classes. But either way, like there's still a constructor being called. It's just that we get the syntax to make it look like it's okay.
Before we move too much further, there was, why does the list collection expression use collection marshal to set the count rather than emitting a call to the int capacity constructor? We may have gone too far that be able to answer that.
Yes, I've commented that code out now, so we can't go back to ASPI. But and also I'm not part of the compiler team either, so I'm not even. That might be one that's good for me to defer. Okay. Any other questions on the chat that I missed? Let's this because otherwise it's not going to like. I can't put it in a method because it won't be happy when we're putting a using inside a method. So we'll comment everything and we'll put that inside a method. So we'll come in here and say static void alias any type demo. I'll put all my commented code in here. Okay.
One new question.
Great. Go ahead.
Maybe you should look at.
Look up.
So can I technically say using global point 2D equals, yeah, it's just easier. Reading codes.
Okay. So the question here, and I think everyone can still see my screen. I'm just going to zoom in on here. If you use this, the question is, oh, yeah, you can't, there's no global keyword in this instance, okay? So good. With everywhere, so think of the alias as scoped to the file that you're in. So anywhere in that class, you can use it, but there's no such thing as like using, let's just do it real quick, global, or is it global using?
Is he asking about global?
Yeah, he's kind of combining the concepts of how we did the global usings here global using and combining with the alias. They're two different concepts. So yeah, that's why my syntax isn't even letting me do it, because those are disparate concepts. Okay. All right, home stretch here. So next thing I think is actually a decent feature is, let me come in here and I'm going to create a little lambda expression, string name, hello world. We've been able to do since C#3. And let me do another one. Actually, we slightly change this. Sometimes Copilot puts me in a direction I didn't even mean for it to do. So we'll say greeting, and we'll say world here. And we'll do a similar thing down here. Say Steve. Okay, so hello world, hello Steve. I've been able to do this code since C#3, nothing new yet. What if I want to come in here and do something like this? Nope, doesn't let me do that. Reading, I'm trying to pass nothing to it. I want, in normal C# methods, we have the opportunity to do optional parameters. So like you put default values, and once you put a default value on the parameter, it becomes optional. But we've never been able to do those in lambdas before, and now we can. So now I can come over here and say default value of, let's say world, and I'll do it with an exclamation. So we have an extra exclamation. So this is now a lambda optional, all optional parameters. So now when we run it, it will just work. So you can see we got the double exclamation, so you know it's actually using the default value as opposed to the one that I just passed explicitly first. Nothing unbelievable. That's one of those features when you look at it like, why couldn't we do that before? Well, they just didn't have time to get to it. Now they do, and just bringing lambdas up closer parity to like a regular method.
You don't need a question mark there?
No, that's for nullability.
It's a nullable.
Like if I was saying question mark, that would be like, oh, nullable string like that. But this is lambda. This is default values for just same syntax. We would have default values for method parameters.
Wait, but if you don't. Yeah.
Okay, so this is going to be lambda, all optional. Oh. Okay. Next one. This is going to be pretty quick. I'm going to create a new file called inline buffer. Now, I want to say right off the bat that this is not a feature you're ever going to use. This is a feature that the runtime team added for themselves. And I guess they said, oh, let's make it publicly available. So we can say we added another new feature to the language. If you get a job on the runtime team, then yes, we'll use this feature. So this is going to be a really quick demo, but you won't use this feature. Okay, so we'll come in here and we are adding, there's this new C# feature called inline array. Notice we have this inline array attribute, and I pre-allocated it at 7. Now, if you remember, it's kind of 10, 15, 20, maybe 20 minutes ago in the demo, we were showing the collection initializer, and I clicked on one of those span examples of auto-generated thing. I said, remember, this inline array has a 3. Remember that. I'm going to talk about it later. So again, inline array, if you're using it, it means you're actually writing code that's like getting generated by the C# compiler. It's really not a feature you could be using in your everyday application code. But you can think of it as it allows the creation of an array of a fixed size in a struct type. So it's super optimized. If you're using a span or a read-only span in your code, then you are using it kind of behind the scenes. So great, but you're not like going to use the feature in like writing the code yourself. Okay, so if I come over here and just say, okay, I'm instantiating a new inline buffer, which has 7 items because we pre-allocated it there, saying you've got 7 items in here. So if I iterate it, it will actually show that, yep, 7 items, 0 through 6. If I make it 8, it's going to throw me an exception, just like out of bounds exception I would get from any other array that I did the wrong thing on. So again, this is something that's, this is something you would use if you're generating that auto-generated code that I'm showing you when you're decompiling. So I'm just showing you very quickly for your own curiosity. When you look at the list of new features added to C# 12, not something you need to worry about in everyday application code. Okay, so this is going to be inline arrays. Oh. Okay, final demo. This is another one you're really not going to use much. Maybe more than maybe once every couple of years. So maybe more often than inline arrays, but again, grain of salt on this one. So very simple code here. C# 1.0 code, basically I'm showing you. I've got an integer, 21. I'm calling a method. I'm echoing that number back out, 21. I'm then incrementing it and then showing the incremented value. And then after the method is done, I'm showing the value again. And everyone sees this is an integer, which is a value type stored on the stack, not on the heap. And so if we execute it, it's going to show 21. Then it's going to show 22 after it was incremented in the method. But then after the method, it's still back to 21 because it's a copy of the variable and you changed the copy that was inside the method, not the copy of the variable that was still outside the method. Again, that's a behavior that's been in C# since 1.0. Now, if we come in here and we say, okay, we're going to make this a ref, and we'll add it to the parameter itself. And notice I'm getting this red squiggle up here, meaning I have to add it up to the call site as well. Now, when we run it, okay, I incremented it, and then even after the method, it's there. So we have this actual reference to the variable here. Again, still C# 1, still C# 1. We don't worry about that too often, but if you really want to pass a value type, the reference to it, you can use the ref keyword. We've been able to do that for years. Now, remember those point releases I mentioned when I showed that slide at the beginning of the history of C#? One of those point releases was 7.2. And in that point release, they added the in keyword for a scenario like this, such that if I change this ref to in, the idea was they wanted to have a situation where you were passing it by reference, but it was going to be a read-only situation. And just by doing that, you may notice that I've got this red squiggle down here. And the red squiggle saying, hey, you can't assign it. It's got to be read-only. Because again, the whole purpose of them adding in was they were doing this like we want to still have the reference semantics, so we have really efficient memory management, but we want it to be read-only. And so, great, we have this read-only method now, and let's comment it out so the compiler is going to be happy. And we also have this warning here. It's fine, it's not an error, but it really would prefer if we use the in keyword here, and now the warning's gone. And that's fine. I'm not even going to bother running it because it's not even interesting. I'm not incrementing the variable anymore because it's read-only. But what is relevant is that you say, well, okay, why aren't they just done with it? What they found was there were some instances where, yes, they were passing it by reference, and yes, they ensured it was read-only, but they found a bunch of cases where they still had to copy the whole variable, the whole value, which kind of negated the whole point of it being efficient. And so if you were using really large structs, that would be a performance. Now, I'm using an int. So you can't get much smaller than that. Maybe a couple things that are smaller than that. So like this really is not relevant if I was actually using an int. But if you're using like a large struct, there were certain scenarios they found where a copy was actually made. So if you passed a constant, or if you had some implicit castings, or if you had to do overload resolution, and they identified 3, 4, 5 scenarios where it actually creates a copy anyway. So this is almost like to kind of correct what they did. So in here, instead of the in, you can, you're back to ref, but you can say ref read only. And now when you do that, again, if we uncomment that, it's going to give us an error saying, no, this is read only. You can't make any changes to it. And up here in keyword's fine, no compiler like warning or anything. Usually ref is the way to go. But in this case, it will not create a copy, even when you have these instances where you have to do implicit casting or method overload. They've kind of optimized this again. If you're on the runtime team, or you're on one of the teams that is processing billions of transactions a day and every byte of memory matters, it matters. But on my teams at Microsoft, they'd have a very difficult time justifying this because I want to say, show me the load test that actually proves this is going to make your code faster. because if you're going to a database, that's orders of magnitude slower. So it's really when you're doing high volume in-memory optimized code is when you might have occasion to use this, not in normal kind of everyday application code. Okay, I lied. There's one more quick demo. So real quick, I'm going to come over here. I'm going to go to my person class, and I'm going to add a new fancy new method. And let's just console write something fancy. Now, I almost hesitate to show this example because it's really not a language feature. So I'm going to add this experimental attribute here, and let's call it SM123, SM for Steve Michelotti. And this is technically a new feature called experimental attribute, but I can't help myself, not a true language feature. It's just an attribute, right? I think it's because it had something to do with compiler. They said, well, you know, it must not be. So, and actually, let me set this aside. So we'll set this aside real quick. This is ref read only demo. Okay. So if I say var person, new person, Steve Michelotti, 21, person, fancy new method, compiler error. Just by the fact, if I try to run it, nope, can't run it. If we look at the compiler error, you'll see it's, oh, we're violating SM123. This is for evaluation purposes only. You can't use this method. The only way to use it is if you come over here, and I think because it has something to do with compiler, I said, oh, let's add it to the list, new language feature. It's not really a new language feature. And so I can come, oh, sorry. I can come over here and say suppress SM2, 123. We can do it in source. Oh, all right. That's my press this in source. There we go. Okay. And now it builds just fine. So if you explicitly express it, suppress it with the pragma warnings, then it's fine. Then it compiles. Then you are allowed to use it. So if I'm a library author that's got a preview method that if you got to be really intentional. If you do the pragma warnings, then you can do it. It's fine, but otherwise, no. Okay. And then finally, interceptors. I'm not showing a code demo of this because this is still in preview form, and it's probably going to go through some changes before they officially release it, but they keep listing it in the release wave of C#12. And it's something that's going to be used by code generators. So the idea is if I have a class called C that has an interceptable method, and notice I call this method 4 times, okay? So let's go through each one of these. So first off, I call this method up here, and it's going to print interceptor 1. Okay, so in this instance, it's going to come in here, and it's actually going to print this. Not interceptable, it's the intercept location. This attribute is going to say, grab this file, this line number, this character, and it would actually say like line number 3, character 4. It's just like they put comments in there for brevity. And you could say, well, wait, how are you going to know the exact character? Well, it's because this would be used in the context of a code generator that would know the exact line and character of your code. And in this instance, it would, instead of invoking this method, it would invoke this method down here. And so same deal here. If I come in here, this is line number, we're going to call this line number 2. Well, this one says it wants to capture line number 2. So it's going to say other interceptor, and sure enough, other interceptor. Same thing here, line number 3, which is other interceptor, is going to put other interceptor. And then this one here is just going to print interceptable 1, which is this one, because none of these intercept locations said anything about intercepting line number 4. So I know it's a little odd, but again, it is intended to be used for code generation scenarios where you want to replace a method that's being called. And it'll be interesting, I think, when we see uses, but again, for everyday code, nothing you have to worry about. Yes.
So this is probably using source generators, not reflection on other numbers, right?
Correct. It'll be used in conjunction with social. But again, still in preview. So even some of this syntax, I put it on a slide, but could change before the final release. So take it with a grain of salt. Okay, we covered a lot. So 8 features I said that we had. We spent most of the time in these first 2 because I think these first 2 you'll use a lot. I really like these alias any type and the default lambdas, but you know, it's not necessarily something you'll use every day. This stuff you won't use much. You will not use inline arrays ever. read-only ref parameters once a year, once every couple of years, experimental attributes, interceptors, that actually might be really interesting. But jury's still out on that because it hasn't been released yet. We'll come back a year from now and see where we are on that one. That actually could end up being interesting depending on like the use cases that it's going to be applied to. Yes.
Could you use the ref read-only parameters to kind of use that you're concerned with the primary constructors, or something in class could overwrite logger, that sort of thing? Yeah, we said if the one concern of the primary constructors that once you put it in there, someone could change the pointer to logger to something else.
No, I mean, that's just the regular read-only keyword is doing that job sufficiently. And that was in the code that I put in there. You put read-only there, it will be read-only. No one else can assign it at all. So that final code version that I ended up with, it will have the desired effect of what you just described. By the virtue of the fact that I've got read-only keyword right now, I cannot assign to it. Logger down here, no, it's not going to let me assign at all.
Yeah, but you could use read-only in the constructor itself.
No, good question. Yeah, so you're saying, can I use the read-only keyword up here?
Exactly.
Great question. My prediction is that in a future version of the language, you will see that. Because you think about the discussion we had here, I was like, well, this is nice. I got to save 12 lines of code, but I lost the ability to do read-only. I lost the ability to do that. So that was something that the language designers did get feedback on that. So they're talking about maybe in the future, they may allow you to put a read-only keyword up there that will result in this. So you can get rid of all this code and make it more succinct.
To his original point, you could put ref read on. I mean, it might not be what you want to do, but
Be a byproduct for.
Yeah,
it would be weird. but
it would be definitely weird. Yeah. Okay. Guys, any additional questions on the chat I have not answered?
There's only one. Can we pass optional parameters to primary constructors like methods?
Yeah, you can put just like any constructor, you could have defaults on the parameters. And once you have a default, that means it's optional. And primary constructors are no different than a regular constructor from that perspective. You can do that as well. Okay, yes, another question.
Just a thought, what is your opinion? So based on the, from C#8 to as of now 12, it seems like the semantic or syntax is reducing in language footprints or coding footprints. I have a feeling that they are going or aligning toward just like a Python programming. So C# is good for object-oriented programming, function programming. But at this moment in time, for last couple of months, right, I had a feeling that C# might be the language for data science. The way, especially the collection is marvelous feature. The way you presented it today is really, really impressive. It's just like aligning with the Python for a data science work type of things. Any thoughts you have?
So I think the question is like, in terms of like philosophically, the direction that the language designers are taking C#. Yeah, I mean, I think it's even maybe broader than that. Right? That's why I think it is good to look historically, because if I look historically at what the language designers have done, even going back to the dynamic stuff, that was back in C#4 when Ruby was really big, Ruby on Rails. And so they were trying to say, okay, can we keep our language at that time modern by coming in with these? And it turns out people really like static typing in C#. So they were responsible and conservative with how they introduced dynamic into the language. Even a lot of the things like lambda expressions, more functional type syntax. They're looking at languages like F# and some of these other functional languages. So like, how can we borrow from these functional languages to bring some more pleasing syntax into the language? And so as we kind of find ourselves now in 2024, I think they're going to try to continue the same way, which is like they want C# to be a very much all-purpose, like if you're building CRUD web APIs and web apps, it'll be great. But if you want to do some data science and some Python, some like Jupyter notebooks, it'll work great for that too. And if you want to do dynamic programming, there's some valid concepts in there. If I think what they're trying to do is, and it's difficult. Like I'm not saying I have all the answers if I was on the language team, because it's like you want to innovate, but you also don't want to do it in a gratuitous way where you add these features that are like, what were we thinking 10 years ago? So I do think that, I'm not sure if I'm really answering your question, but I do think they're going to try to innovate the language. You know, like Java has been a little stale with new features they've added.
A lot of
And very stale. And so they've been very enthusiastic about like keeping C# fresh and modern and innovative without like adding features that are people are going to be like 10 years from now, what were you thinking? And so I think they're going to continue to look at the landscape and, you know, what people are asking for and that kind of thing. And I do think, especially with the, you know, the rise of AI and data science, as you mentioned, it is one of the languages that, I mean, C# and Jupyter notebooks 10 years ago.
Exactly.
No one would
C#
think of
Jupyter,
that.
exactly.
Yeah, it's not common.
Yeah.
So I think you'll still see things continue to go in that direction, whereas still, if you have super high performance server code,
Right.
C# is a perfectly great choice for that. You don't have to revert to Rust and C++. I mean, those are great too, but you can write really fast code with C#. And so they wanted, especially with all the teams at Microsoft that are going to the latest versions of .NET, .NET 4, .NET 8, they're writing a lot of very high volume performant code. You know, I think they'll keep going in this direction.
And practically, my current assignments are for the last couple of years, right? Is on AI, machine learning, data science. But in the end, honestly speaking, C#, when it comes to the volume, speed, no comparison. Well, literally, Python is good. I can do a quick and dirty things in a small sets of volume data, but for a high performance volume, in the end, I end up with a C#.
Yes.
So why don't I have if I have a feature like this collection, it's really, really catchy.
Yeah, that's
It's so impressive.
absolutely.
Maybe big numbers.
Exactly.
Better than that.
Yeah.
All right, well, as I said, the PowerPoint, the 4 slides on the PowerPoint, plus I'll zip up the code samples and make those available for download. Either I'll put a link out on Twitter, or maybe I'll just give them do you have a download link on Meetup or whatever? I can put a link on Twitter. So for people interested in getting the code samples for PowerPoint, within the next 24 hours, I'll put something up, and you can always, message me if any follow-up questions. So as I said, thanks for coming out tonight. It was great to actually present to a live engaged crew rather than just a flat screen where we pretend like we're in the same room with each other, but we're really living our own lives. So thanks everyone for coming out tonight.
Thank you so much.
Are you at the resident office or from here?
Out of this office, yeah, my desk is up on the 14th floor.
Oh, okay.
Yeah, so, and I didn't even realize that the meeting was here tonight, because I think of it as the other building